Question number 8. Show that the equation there has a solution between 2 and 3. Now, as soon as you see solution, that means roots, then you think, where did we do this kind of things? Oh, it's the last chapter. Can you recall that? Chapter 13? Numerical solutions of equations. And before I start, I'm just going to take you back to the textbook. Okay, so let's just look at one example. I think it's also a build-up, and then all the examples is more or less the same. But it's not so difficult, although it's new in the syllabus. Okay, but let's look, and I'm going to show you. I'm in the AS-Level Mathematics textbook, y equals mx plus c. I'm on page 552. There is a nice example. Very straightforward, also with different A, B's, and C's. So verify by calculation that the cubic equation has a root, a solution, a root that lies between x is 0.7 and x is 0.8. Okay, so I first give it a name, and then I just substitute 0.7, and then I substitute 0.8, and then the change of sign. So the change of sign indicates the presence of a root between these two. Okay, so then I'm looking out for the change of sign. Then show that this root also satisfies an equation of the form where the values of a and b are to be found. Now, it's almost like I simplify that equation. Now, it's actually the only way where, or in this chapter, where they sometimes, if I look at this, I see, oh, there's only an x squared. So it means, what did they do to get rid of one of the x terms? Is they divide all the terms by x. So keep it in mind. In this chapter, it happens. So I divide all the terms by x, and now I have an x squared. And now I just go, and I want to see, what do I do? In this case, I'm going to take, okay, I first make this one term, and then I cross multiply. There, I did that, just to get that x alone, and then I divide. Just take note that sometimes you can rearrange it at one form, and it's not going to work because it's not going to come to a center point. And then sometimes you have to take another method to rearrange it. But I think most of the times they will tell you where you must end. So if you followed this route and it didn't come to that, then just follow another route. Okay, but now I have that. And now with these values of a and b, use the iterative formula, this is now, to determine the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Okay, now if they don't say, note, any value, usually if they tell you, start with the value. If they don't tell you, you can start with any value between 0.7 and 0.8 because you know it's there. But I start at the middle there. Sometimes they will tell you, like in the question in the paper, where to start. Then I just want to refresh your memory on this. So what do I do to get this? And this is, so I'm just going to press the value of the one that I choose, or the one that they give me. So it's 0.75. So I press 0.75, okay? And then equals, that's all. And now it's in your memory. And if you start now, every time that you see x, you just press answer. Please remember that bracket. So it's 2 answer squared, or bracket, 2 answer squared plus 3, close the bracket, divide bracket, answer squared plus 5, close the bracket, equals. And then just make sure, if they say correct to, I think they said 4 decimal places, let's just see, to 4 decimal places. So approximate it to 4 decimal places. Okay, there it is. So you can write it down and then approximate. Okay, and then just by pressing equal, you will get the second one. Okay, and as soon as you approximate it to, again, 4 decimal places, I get 0.7387. Okay, so let's just see what was the question. Give the result of each, okay, to determine the root correct to 2 decimal places. So in this case, although I give 4, but if I approximate to 2, as you say, okay, let me just write it. This is 0.74, and if I do this, as soon as I get the same answer, then that 0.74, that is going to be the value that I'm looking for. Okay, so to 2 decimal places. It seems to me I didn't show here the answer. So therefore 0.74. You can just end by saying that. Okay, give the result of each to 4 decimal to determine, okay, they just want that, and that was the root. Okay, and that was the whole story. So let's just go back. Remember, this is x1. The second one is x2. Then the third one is x. So the one that you choose will be already x1. Okay, let's go back to the question. Okay, let's just go and do the question paper. Where is it? I think it's this one. Okay, let's just move a little bit down. And I think they said this answer is actually good answered. And I think it's very straightforward, although it's new work. But it's most of the time, especially this is a basic one. Show that the equation has a solution between 2 and 3. So what did I do? I told you I just give it first a name. Let fx be x to the power of 3 minus 4x minus 2. Okay, then I'm going to substitute. So I'm going to put the 2 in. So it's 2 to the power of 3 minus 2 minus 2. And if I simplify that, that is going to be 8. Can you see that? And that's minus 8 minus 2, but it's going to be negative 2. And then I'm substituting the next one, 3. So it's 3 to the power of 3 minus 4, 3 minus 2. And that will be, it's going to give me 27. Oh, let's just get the pen correct. Minus 12 minus 2. And that is going to give me an answer of 13. Can you see the change of sign? So just end by saying, therefore, the change of sign indicates the presence of a root or a solution between x is 2 and x equals 3. Okay, now we go on. Now, show that the equation can be rearranged. So they help you, they tell you. Now, as I said to you, because you look, okay, there was a square, that's why they took the square root. But start with the equation, okay, this is going to be my equation. And to get rid of one of the x, divide all the terms by x. Equation is like this. It's fine what you do as long as you do it with all the terms. So this is going to be x squared minus 4 minus 2 over x. My pen, I must just calibrate it after this question. Okay. Now, I'm just going to end up with saying, okay, I have x2 there. There is my x2. Take the terms over because I start to look there. So then it's 2 over x if I take that one over, plus 4 if I take this one over. And now, because it's just showing me, so it's just a positive one that we're going to take there. Okay, we'll come now to the marks. Okay. So I think maybe we just handle the marks, that we don't at the end have so long to do the marks. So just the change of sign. So I think in this case, to get that two values, the positive and the negative, and then to establish to say the change of sign. Okay. And in this one, it's for rearranging to get the x squared, okay, and then to establish to get that question. Okay, let's just go on. Now, starting with x1, x1 is 2, so they tell you. Okay, so in this case, could have been any number in between or 2 and this, so they start with 2. So they tell you. Use the iteration formula, this is the one now, to find x2 and x3. Now, okay, so let's start by saying, I know now x1 is 2. Okay. So if I'm going to use that, so to find x2, okay, so it's 1 plus 1, So it's going to be 2 over, okay, and I'm going to say just there, x to the power of n, okay, the answer. So let's just, with the answer there. So x, n, so it's that second answer there, plus 4. Let's rather just keep it a n. Okay. But all that you do is, okay, let's just go back. So we're just going to put the 2 in there. That's basically what we're going to do. But remember what I said, press 2, then press equal on your calculator. And now you start. But also remember to put a bracket there. So say square root, and then bracket 2, divide that answer. Don't press 2, say answer, plus 4, close the bracket, equals. Okay, and very important, to 5 decimal places. So I'm getting 2.23607, because it was 6, 7, and that 7 make it a 7. Okay, 1, 2, 3, 4, 5. Now, for the next one, for x3, you can just press equal, and I get, and again, 2 point, and count again, 2, 1, 2, and then it's 3, 3. So 5. So that 5 makes the other 3 a 4. And that is then my x2 and my x3. Okay, and then, so again, I think straightforward. If you come and you approximate correctly, they'll give you there. Then the last one, find the solution of the equation correct to 4 decimal places. Now what you must do here is you must continue, because now they said 4 decimal places. Now you can write it here on the side. Now if you approximate, let's approximate that one to 4. So keep your calculator. So it's 2.236, and that would have been 1. Okay, so let's approximate this one. 2.212, and that would have been 3. Okay, still it's not the same. Press equal, and it's 2.2145. Okay, and then it was 0. Okay, I'm just going to, I don't want to write it there. So 125, and then I press, they said correct to 4 decimal, find the solution, and then I press equals, and then it was 2.2143. Okay, and then I press equal, and then it was 2.21. Do you see? It starts, it keeps on, so therefore it's 1 mark. So it converts. Come on. To, you don't have to write this. You can just say 2.2143. So please don't forget, just continue. Don't write it there, because they only want that 2. Write it here on the side. And then you just, every time you approximate to 4 decimal places until you start to get the same answer. And that same answer is the one that they were looking for. And that's how you do it. Or you can write that in this space and then just end up by saying, therefore, this one. That would be also correct. Question 9. Find. Now you see it's further integration. Now just take note that we are going to simplify this. There's just one term at the bottom, so we're going to divide it into the numerator, and then we're going to integrate it. I want to take you to the formula sheet. It's the first thing. It can help you, but I think it's not so clear. You have to go a little bit further, and then I'll take you to the textbook. Okay. So this is the extra page. I just want to see, let's just see the integration. Let's see if it's, okay, I think it's here. Now, it's going to be E. Now, the problem is just here on the formula sheet. it's just the basic one. There's not a 2 or a 3. So, and I'll show you now in the textbook. So it's just standing the basic one. Just like in question 5, that was in question 5. It was also just the basic one and not going a little bit further. I just want to show you while I'm at this formula sheet, this is not formulas for you. This is actually pure mathematics free. I think it can be that this happened, and then you have to choose out what is for you paper 2. That is paper 3 in the Cambridge syllabus. But so it can happen, but maybe in the future, I think the same with this formulas here. Okay, so that is also not for you. So in the future, they will take it out. But just take note, it's not to say that all the formulas on the formula sheet you are going to use. It's just basic is going to be a help. I just at the end, I will just come to the formula, and I think I'm just going to mention it now. I think at the end, I'm going to integrate somewhere cos. And again, I want to show you, if you integrate cos, it's sin. But again, it's just the basic one. So I'll take you to the textbook. So I think a good idea is to take the textbook, the AS-Level textbook, the last page, the summary page, and just memorize. It's 13 pages. Just memorize that formula as you are memorizing things in biology, things in history, and that learning type of subjects. Okay, so that you just can come and see, okay, it's not so clear, so let me just go back to my memory. Okay, but let's go back. So that is what I can show you on the formula sheet. I want you to take you then, okay, so I'm first going to take you to that page 545. I just want to search for it. Let's just see if I find it there. This is 415. Just want to see if I'm having the correct one. 545. This is question number, okay, no, I'm not there. There it is. There it is. That is the question I'm looking for. Okay, just wait for it to close. Okay, let's just try again. Okay, so if I look at this formula, I can just show you here. I just want to show you there. I think you can see, there you see both. So if you see that there's something, a coefficient in front of x, then it's 1 over that coefficient, and you just rewrite that exponent just the way it stands there. And if it's open, indefinite, so then just don't forget to write the plus c. They're going to penalize you. So I just wanted to show you that formula. Okay, but I think let's start, and then I'll come back if it's necessary. Okay, let's just see. Let's just move down. Okay, so what we said, we are going to do it like this. So it's going to be 4 over, as I said, I prefer always first writing the thing as it stands there. I think the space is enough in this question papers. And even with me writing. So what you can do, because it's not a very long sum, I can now say 4 over e to the power of 3x minus 2e to the power of 3x over e to the power of 3x. And remember, we are integrating to x. That is just saying that. Okay, so if I bring it up, so it's going to be, again, I'm just getting it ready. I didn't integrate yet. Then it becomes negative. Then this cancel and it's just negative 2. Okay, now it's better. Now it's more clear. And I showed you that. So what I showed you was just that 4, it's just 4 over, and that is the value of negative 3, the value, the coefficient. Okay, and then I'm just going to again and write that as it stands there. And then I'm just going to put a x. And don't forget your plus c. They're going to penalize you. And that was the final answer. So the final answer was negative 4 over 3 e to the power negative 3x minus 2x plus c. I saw somewhere in the report that they said you don't have to make this to positive indices. I just want to see their stance. There is no need to write this, or any other exponents or indices with positive indices in the final solution. So it's not to say that you have to take it to the bottom to make it positive. This is also correct, 100% what they want. Okay, so I think they will give you, if you did that, and then for the final they will, and please don't leave out the C, because it's open, indefinite, the C must be there. Very, very important. Okay, let's look at the next one. It's still integration, it's just now trigonometry coming in. And remember that I showed you that it's going to be sin. But before we go to this, by expressing, and they're helping you, they say to you, 4 cos squared x in terms, they want you to first go before you integrate it. Now, I'm going to take you to the formula sheet, and I'm going to show you how I play around with that, but then I'll take you to a place in the textbook where I did it for you. But let's first go to the formula sheet, and I'll show you. So if you could not recall that place in the textbook, I just want to see. Okay, I think it's this one. Oh, yes. No, it's not that one. Yeah, but yeah, I can work here. Okay, I think I see it. So this was on, can I just give you on page 18. On your question paper at the back, you will find this. Okay, now if you see, this is double angles. Now, if you use this, there's actually 3 options, but this is the option that they want you to use. Okay, so I'm taking it out. So it's cos 2a is equal to 2 cos squared a. I'm just playing first with this one. Okay, now make this the subject of the formula. Then I have cos 2a plus 1 equals 2 cos squared a. And I divide 2 and I divide 2. So it's actually a half cos 2a, or it doesn't matter which one is in front, or 1 plus was cos 2a, and that is cos squared a. And that is what they want me to replace it with. Okay, but let me take you, so you could just use the formula sheet. But let me take you also to the textbook. I wrote it to you, or I did it for you in the textbook, and I'll show you quickly the question. Okay, let me just find, we are now busy with question 9, and I just want to see that page. So it's 545. I just want to don't open the incorrect one. Okay, that one we already did. So let's just go back. 545 is fine. We did that one. Then 527, that one. So in the question book, in the textbook, question book, textbook, okay, let's rather keep it like that. In the AS-Level Mathematics textbook, y equals mx plus c, on page 5 to 7, I did it for you. Did you see? Okay, so you could have used that one also, but then they would have said sin squared. They said cos squared, so that's why I used that option. Then I took the 1 and I divide 2, and that is what I'm going to substitute in that place. Okay, so just take note, I did it for you there. Now then, okay, I'll take you now. I'll first go to the question paper again. Okay. So if I'm at the question paper now, okay, so I can now write that statement down. Can you remember from the formula sheet? Can you remember the statement that I showed you there? Let's just write it down. I came to that I said cos, okay, I want to write it here at the side. I said cos squared, they call it x, it's a half, okay, and now either like the text, doesn't matter, it's plus, so it's 1 plus cos, let me just 2x. Okay, so I'm basically just going to replace. So let's start with the question. I'm starting with the question. I say 4 cos square x dx. Now remember, it's 4, so I can only replace this. Okay, but it's fine. And now I'm going to replace it. So 4, and I replace that. So I'm saying a half 1 plus cos 2x, and then I say dx. Okay, then this is going to, if I multiply it now out, then I'm just going to get 2. Do you see that? Okay, so I didn't integrate yet. You can put the 2 in front. It doesn't matter, have an influence if you put it at the front. So it's going to be 2. This is the constant. And then it's just going to be 1 plus cos square x. And I didn't integrate it. Now I'm just going to take you back to the textbook just to revise a few formulas there with you. So let's go to page 528. Okay, there is 528. Okay, I just want to show you. I said cos becomes sin, but that's the basic one standing. But I think if you look at this example here, can you see? So, okay, there I did it. Do you see? That is just a free. It's more or less the same. It's just now free. And then I did this. But I just want to show you. If I integrate, it's just becoming x. 1 is becoming x. But this is becoming a half. And then the cos changed to a sin. And I keep that the same. That is what I wanted to show you in this question. And then I can just show you a final, and that's 5 to 6. I just want to see why I want to show you this one. I just want to make it a little bit bigger. Okay, it's basically just to show you cos 2x. It's a half sin 2, but you keep the 2x, almost like the e. You keep that exponent. Okay, the same. Okay, that is just now sin becomes negative cos, and that is what I just wanted to show you. But let's go back to the question. I think from here it's very easy. Okay, so let's see if this is the question. Okay, so it's just going to be 2. And now I'm going to integrate. So this becomes x. Now can you remember what this becomes? This becomes a half. And if you integrate cos, then it's becoming sin. But it's very important that you keep that 2x. And it's very important that you say plus c. Just put the c there. Okay. So basically, my final answer is just going to be 2x. 2 times a half is 1. So plus sin 2x plus c. And that will be my final answer. Right, let's see if I showed you in the previous. Okay, luckily I showed you the marks. In this one, you will get a mark if you bring that in. Okay, then you will get a mark as soon as you... did I integrate already here? No, I just simplified at this page. So, and then I'm basically will get, but if you leave something out of the answer, you will lose a mark, especially the plus c. That's not so difficult, so just make sure that you know that basics.